Biyun, yeah. Thank you guys for joining this session. This will be a really exciting session, 1 hour long, but I believe this will be some really good topics to cover. So if you go to the next slide. So together with the SecCom team and also Byung, who is joining also our sessions and is also contributing to the architecture subcommittee, we'd like to share with you some info about the Jakarta global requirements and best practices. And on the next slide, I'd like to share with you some requirements that for the last few releases we are working on. I could say that we were the pioneers for the global requirements when the new process was onboarded. So for the completion of the Python and Java languages update. And we follow up with the next items like continuation of packages upgrades in the direct dependencies, continuation of best practices for the badging. And please keep in mind that recently LFN changed the naming from CI badging best practice into the OpenSSF best practices badge. We have also the best practices that we are working on, which are the standardized fields for logging for security, and we will have the more details covered later in this session. And we are working also with the OM team and integration with the using basic images from the integration team. And we have also the important initiatives that are focusing on the standardized feature intake templates and software bill of materials. So yesterday we had a session with Mudassar on the SBOM. Maybe just the last item on the differences between the global requirements and best practices. So the best practices apply for example, for the new container.coms or some new project. And global requirements are impacting overall ONAP. So not only for the new code, but also for the code that is already in place. So let's move on with the more details. So
thanks, Pavel. Appreciate that summary there. So hello, everyone. My name is Bob Heineman. I'm going to be co-presenting with Byung on this topic today. I'm a member of the security subcommittee, and one of the topics that we've taken up is sort of logging as a security concern. So just to summarize what we're going to be covering is we're going to talk about some of the work that we've put in place for the Jakarta release. And then we're going to be talking about sort of the follow-on work with that. So things that, we've accomplished, and then the work that we're currently doing now to hope to get into the release after Jakarta. So just briefly, just to introduce the topic area. So for those who don't know, ONAP is an orchestration software. It's more of ONAP's an umbrella term, and there's a lot of different projects that fall underneath of ONAP that make up the platform. And one of the key use cases for the orchestration software for ONAP is really the orchestration of telecommunications network. And obviously, since it has such a centralized role in those type of applications, losing control of that definitely would have sort of trickling effects or devastating effects through the things that are controlling it. And so to take a look at that, and one of the things that we're charged with is come up with mitigations and techniques to secure the platform. And as we heard from Pavel before, there's a lot of different initiatives that we're involved in. Even there's some more things that are going on that aren't on that previous slide. But logging is an area that we've been focusing on. We feel that is really of an important area, and not just logging, but logging for security. So what is the data that we need? What is the right kind of data that needs to be logged out that will support strong security analytics downstream? And really our goal is we're looking towards the end users, and such that when they bring this product into their environment, there really isn't a need for code changes on their end to be able to get the data that they need to generate effective security analytics. Next slide, please. So as we start to take a look at this topic, we started to, something that's been useful for us in terms of work planning and scoping the effort is understanding what is the life cycle of security logging. And so we've represented this life cycle with a pie chart here. And we start out with sort of the green slice, or the generation of the data. So what is the data that we generated? How do we generate it? Then after it's generated, it needs to be collected and aggregated. So there needs to be some approach to that. And then once you have this repository of data, there needs to be some sort of monitoring, and then some alerting based upon that monitoring. And then some would argue that there could be a fifth slice to this pie, where there's some sort of action that happens to that learning. Some sort could be a closed loop action or open loop action. But for the sake of scoping and what's in scope for ONAP, we feel that both the generation and the collection is within scope for that platform. And that's what we've been working towards, and that's what we'll be focusing on today. I'll be talking about the generation piece. So what's the data that we should be generating? And then I'll be turning it over to my co-presenter, Byung, and he'll be talking about architecture for collection. And just a quick other caveat is that the work that we're talking about today it's referring to just the platform components themselves, the components that make up ONAP. Not this isn't intended for the services that would be orchestrated by ONAP. So it's a key distinction. Next slide, please. All right, so our motivation approach, we talked a little bit about our motivation, but I think it's worth reiterating that our end goal is that, we want our end users or the operations infrastructure teams that use ONAP to have the data available, so that they can use the tools that they have in their environments to create security analytics. And with that goal in mind, there's a challenge presents itself, such that, what is the data? What is the data that we need to enable those teams? And fortunately, there was a corpus of information available that details how an adversary operates and exploits containerized environments, which ONAP runs on top of. And this corpus information is the attack framework by MITRE Corporation. And specifically, they had a overlay to this framework that detailed adversary behaviors within containerized environments. So our approach was sort of take this information and review it against the data that projects in ONAP are already logging, and then essentially just do a gap analysis to understand, is this sufficient enough? Is there other data that we need to bring in? How do we do that? And so really that was the bulk of the work initially, is doing that analysis. Next slide, please. So what we're looking, let me explain what we're looking at here. This is sort of a matrix from the attack framework. This is the container matrix. It's been sort of reformatted to fit the size constraints of a slide. But initially, this is this is supposed to read left to right without a break in it. And at the top of each of the columns, you see a bolded text. And these are broad categories of types of adversarial behavior. So things like initial access, how an adversary gains access to an environment, execution, how they how they execute commands in that environment, persistence, how do they persist in there, and et cetera. So privilege escalation, how they evade your defenses, et cetera. All the way down to impact, which is which describes, okay, an adversary is in your environment. They have a reason for being in that environment, and that's what the impact category documents is, ultimately what they're going to do. This is a heat map. So like I said, we had reviewed the data that was already being logged against the information that was in this matrix here. And so in each of those columns, we see color codings. We see yellow, green, orange, and that really indicates, that's supposed to indicate the data that we're currently logging is sufficient to detect this type of adversary behavior. The yellow indicates that there's some data that we may or may not be able to detect. So sort of almost like a partial coverage. And then the orange indicating that there's no data available currently that we could detect this type of behavior. So if we just look at the green boxes, that represents about a third of the all the documented adversary behavior and containerized environments. So with the data that we currently have, currently we're logging, we could only detect about a third, or to put it another way, we're missing 2/3 of the adversarial behavior based upon the data that we have. So those were basically our findings with the current set of data. So there was a pretty significant gap that we had discovered. So, but that data was very useful, and we were able to take that and understand, okay, what else do we need to bring into the environment? What other data do we need to get better coverage? Next slide, please. So just to talk about some of the, the next steps for that, what were our conclusions from those findings? And really, we had discovered that there really only needed to be an additional 5 pieces of metadata to include with those already required fields, such that it would raise us up to 85% coverage. In actuality, it really would be a 100% coverage. The other 15% is referring to denial of service activities, which we felt that logging is not a good mitigation for denial of service. So if we were to remove those adversarial behaviors from the matrix based upon those reasons, we're really 5 fields would get us 100% coverage. So really, it would get us that other 2/3 to significant increase in the quality of the data that we could use to generate good security analytics. The other key finding was that these data types, this metadata that we would need to include, is not at the application layer. It's data that would be from the containerized environment logs, or the container orchestrator logs, in this case Docker logs and Kubernetes logs. And so things like image registry, Docker, container names, pod names, and things like that. And so really our approach was to try to understand, is there a way we can take the existing set of data and enrich it with this Kubernetes and Docker metadata, and would really significantly increase the quality of the data that would enable security analytics downstream. Next slide, please. So this is just a very high level view of the recommendations based upon the work. I'll put my I'll put my email address in the chat. So if anyone's interested in some more detail about the analysis or the requirements that we developed please feel free to reach out to me or Pavel, and we definitely can share that information with you. But just to summarize, you know, in totality, to get full coverage of the adversarial behavior for containerized environments, there's really only 15 fields of data that's required, and nine of those 15 fields had already been are being logged, mostly logged within the ONAP environment. These are fields that had been specified from some prior work, the logging specifications project, and a logging document that came over from the initial open source of the AT&T eComp software. And those fields are documented here on the slide in green. We call them green fields because I colored them green. And so these are the fields that for Jakarta we have as a best practice. We'll be looking to work with the other projects that may not be logging all of these fields for the release after Jakarta to get this to be a global requirement. The fields that the yellow fields, or the metadata fields, that are really going to give us that additional coverage that we're looking for, are the fields in yellow here, or the fields under the new fields recommended heading. And as I had described before, these fields all deal with metadata from the environment that that ONAP is running in. So container name, container image digest, container ID, role and attribute ID, and then the protocol from the requester itself. And so those fields, with that in mind, we've come up with a sort of an architectural approach as part of the aggregation and collection architecture. A mechanism allow us to enrich the data with these fields that the projects are already logging out. And so with that, that's work that my co-presenter Byung has been working on, and he's going to take some time now to walk you through what that architecture looks like, and pretty excited about it. As I said, it's really going to up the security game of the ONAP product in terms of security analytics. So with that, Byung, I'm going to hand it over to you.
Thank you, Bob. Okay. So this page describes the ONAP logging architecture principles. And ONAP SECOM and ARCOM define these principles. So first of all, ONAP logging architecture, they decouple log generation from log collection and aggregation for system visualization. This is very important concept. So for simplification, flexibility, extensibility for logging, and also enabling customization by vendor. So this is open architecture, and logging no longer managed by the ONAP application itself. And now we just decoupling the generation done by ONAP application, and the rest of the function by the open source log stack. So it's a very important concept separation. So for that, an ONAP application should not concern itself for routing or storing of its output stream. So it's not their concern any longer. And as currently 80% of the ONAP runtime, the running process, write this log data to standard out and standard error. I think during the Jakarta timeframe, we expect 100% of ONAP the component write the logs data to standard out and standard error. So another principle is archival destination should not be visible to or configurable by the application ONAP. This is for separation of concern and also security reason. So application, looking at the application itself, they don't know where the destination of the log. This is very critical for the attacking the prevention situation. And also we are using the containerized environment. So one containerized environment just coming up and down based on the need. So transferring transient local log data in the ONAP container, which is very volatile, to the separate and centralized or the even distribute long-term log storage is must. This is the basic principle, logging principle in the containerized environment, and for security, persistence, and aggregation reasons. So since we separate log generation from log collection, aggregation, persistent visualization, ONAP supports and leverages open source or standard-based logging framework for integration by the vendor or operator and extensibility, putting additional function without impacting ONAP core application or customization by vendor. So for Jakarta or the Con release, we plan to ONAP provides logging reference implementation. This is just only reference implementation and allows the logging component stack is realized by choice of vendors. So vendor, they can use this reference implementation or based on their business need, they can swap this log component stack with their own function. This is the basic logging architecture principle. So we're not leveraging existing logging framework. We don't want to make this ONAP logging as ONAP proprietary way. So we try to move away from that the restriction, and we try to make it open. So that's the architecture principle. Okay, so outcome and second work together on this. And I'm gonna move to next. This is about the ONAP logging architecture, how we leverage open source logging frameworks. Again, I mentioned before, ONAP support open source standard-based logging architecture, which is decoupling the log generation from the log collection, aggregation, persistent visualization. So if you see the diagram here, and the ONAP is responsible for log generation only, and the rest of the function will be taken care of by external log component stacks, as you see. So as I mentioned before, all ONAP component push their logs into the standard out, standard error. So any standard log pipe can work on this log. So if you look at the diagram, the ONAP component in the application container, they push their logs through the standard out, standard error, and finally the probably forming the log file. And then there's several options, but here, in other words, a containerized application write every message to a standard out and standard error interfaces. So now we get ready, to use this log file by some stack. So this is what ONAP responsibility. So this summarize allowing the log component stack is realized by choice of vendor because ONAP doesn't dictate these function. This is up to vendor, or we just provide reference implementation. And then for the containerized environment, transferring the log data into a different location is very important for many reasons. The environment characteristic of the microservices, and also the security perspective. So ONAP log will be exported to different and centralized location for security persistent aggregation reasons. Instead of using ONAP proprietary way to handle this log management, we leveraging the open source. So we deployed some kind of log collection agent, and which collect the log input from, they monitor log file in the part in the ONAP the application. They monitor this log file or some other way, and then they collect this information into agent. Once agent collect the log information, they forward to aggregator as needed. So log collector send logs to aggregator in a different container. And then the following aggregator send the logs to centralized database in a different container. So as you can see, we can move the log data into more deeper and deeper. So it's much harder attacker can attack that log information. So here in this architecture, we define 4 logging functional blocks: collector, aggregator, database, and visualization. From the deployment perspective, we plan to deploy collector/folder every Kubernetes nodes. So we're gonna deploy this agent every single node as you define here. and then aggregator less number, few per Kubernetes cluster. And database in this POC, we try to deploy one per cluster to try to centralize. Of course, we can using multiple pods for HA, but for initial proof of concept, we try to test with the one database, and then visualization also one per cluster. So for ONAP reference information, we chose for database, we chose Elasticsearch. For collection, we chose FluentBit, and then aggregator, we use FluentD, and the visualization, we chose Kibana. The reason we chose this reference implementation, the choice is somewhat related to a licensing issue. So in ONAP, we used to use a different open source, and you can probably remember ELK structure, but we see some licensing issues. So for this reference implementation, we plan to do, we use these the tools, Elasticsearch, FluentBit, and the FluentD, and Kibana. So as you see, once the log is sitting in the log temporarily, and then FluentBit case, it has a multiple input plugin. So using the plugin, they can monitor the log files, and then they can bring into this collection agent. And then, and this collection agent additional job is to add container metadata. So collecting container metadata is not responsible handled by ONAP application, because ONAP application, they should not know about this container, the metadata, they don't need to. So we're gonna collect this additional container metadata externally. So that means ONAP application is, they can simplify their log functions. So here, an additional the characteristic of this the architecture, we want to make sure the log data transfer between the component in secure communication line. So here we talk about mTLS, mutual TLS. We want to secure communication. And one of the example is shown here. Within the communication between FluentBit and FluentD, we want to use service mesh-based proxy. So as you know, ONAP already, OEM team already, they're forming the service mesh-based secure communication. We want to extend that the area. So any other communication between components, we plan to leverage service mesh proxy for secure communication, this example. But it's not just for this connection. So here, as you see the note, all inter-component communication is secure by leveraging service mesh. This is the preferred solution. That's another way you can manually configure a certificate, and then you can put some mutual communication handshake manually, but that's the old way. So we try to avoid this manual certificate management. We want to automate by leveraging service mesh the way, so it can handle certificate and other authentication authorization more automated fashion. Another one is we want to deploy the application collection agent on every node. One of the methods is that we can deploy FluentBit in this case as a daemon set, so to make sure the pod runs on every node of the cluster. That means this the application node collection agent was sitting on every Kubernetes node, so you can collect all the data from the pods. But typically, the setting of the daemon set requires root access. So this is against the security policy and the recommendation. So we want to looking into a solution on the against the root access for the daemon set. So we want to make sure the FluentBit runs as a non-root user. So we are looking into the solution. And as Bob said, we are focusing on the ONAP application logging at this time. That's the as a start. So there's a similar way to apply this architecture for VNF, CNF, XNF collection. So if there any event happen in the VNF or XNF, and we can collect the log information, so they can generate the log, and then we can use this same architecture to collect the information from the BNF and XNF, CNF. So, and also we can collect the system platform the log information using similarly, but in POC, as I mentioned here, this is the out of scope. For initial POC, we focus on the ONAP applications. That's the current goal. So, and then from the generation perspective, and as Bob just showed before, what's the standardized logging field? What's the container metadata field? So we are conforming to SECOM container logging requirement Bob just presented. And then there are standard logging field, which called the green field as a best practices, and also recommended container metadata with yellow field. So you can see more detail from this link. So we try to collecting, when we generate the log, we want to make sure we conform to that the specification requirement from SECOM. This is what we want to achieve. Okay, and then next one, did I miss anything? No, okay. So now we're talking about how to create the logging reference implementation. As I mentioned, one of the big the architecture principle, this reference implementation can be overwritten by vendor by leveraging their own logging stack. That's the important part. And for the implementation, as I mentioned, we're using FluentBit as a log folder, and then FluentD as an aggregation. I put this optional for initial POC because we are focusing on the ONAP application logging at this time. If we collect additional information, additional log information from XNF system information, maybe we can leverage the aggregation. So at that time, we can deploy the FluentD. Okay, and then we using the Elasticsearch Kibana for that function I described before. So looking at the FluentBit in detail, there are several subcomponents. They have an input plugin. They provide many built-in input plugins to collect the data from various sources. And also they have a parser, and they can support the many different kind of logging data format. And also they have a filter. This is interesting, the function I'm gonna explain a little bit later. And there is a buffer, and in case you need to prevent the data loss, you can configure buffer as a file system. So you can temporarily store the information in the file system in case the FluentBit crash. And there's the routing capability, and depends on the input tag and then match configuration. Based on configuration, you can decide which output plugin you're gonna use. So in ONAP at this time, currently, we're looking at the ONAP application through the standard out, standard error. It ends up generating the log file in the volume in the pod. So in this FluentBit input plugin, there are tail the plugin. You can tail a log file. They monitor particular logging area, and they can tail files and bring it to here. And then once they collect the input, then they move into parser. And then parser are looking at the content of the format of the log content. So depending on the format, they can handle differently. So one of the candidates, JSON, we can use for POC. After that, we are moving to filter FluentBit initially, internally. And we're looking at the Kubernetes, this plugin. This is very interesting one because it can extract additional container metadata. So they're looking at the Kubernetes, the environment. They can get the pod name, namespace, the container name, and container ID, and others. That's what Bob mentioned about before about the yellow field. And also this plugin, filtering plugin, can extract additional information on Kubernetes API server, such as pod, label, annotation, others. As needed, we can customize this filter, so collect additional information. Once they extract the additional container metadata, they can append this data to the message from the ONAP. So that means once we pass this filtering, we can create a complete log. The information one came from the ONAP application, one can come from the container metadata. It can formulate all the complete the log each record. So then once we going into the routing after buffering and storing, and then file system or just a configuration option. Once it's done, we are moving to routing. So what happened in the routing is they can using different kind of plugin. So one of the plugin is Elasticsearch plugin on top, and the other one is Forward. And then as needed, you can choose other plugin. But the POC, we try to use Elasticsearch or Forward as needed. The reason we want to use Elasticsearch first was we may not use FrontD for initial POC because no aggregation use cases we have. So if we have it, we're going to use FrontD. If we don't have it, FrontBit can add additional container metadata. It can fulfill our requirement. So in that case, once we collect the output and then generate the complete output, we can use Elasticsearch, and then we forward the log information to Elasticsearch through the secure communication. And then user can visualize this logging through the Kibana. That's the whole end-to-end, the sequence, process sequence, how to collect and aggregate and then store persistence and the visualization. So this is our reference implementation scope. And then, so here as a summary, FrontBit was chosen for licensing issue and also is part of the CNCF. And then it has very lightweight, so it's good candidate to deploy every Kubernetes node. So this is why we chose this. And it has pretty good functionality we expected. And you will read, parse, and filter the log for every part, and could enrich each entry with the following container metadata. So we can collect this information appended to the messages. And then I mentioned about we can use a Kubernetes, the plugin, filtering plugin for these purposes. So if you look at the bottom, the FrontD I mentioned before, act as the logging aggregator for log events from FrontBit. So FrontBit for then there are multiple the FrontBit on the from each node. And then the information coming into FrontD, so merging into FrontD, and then they can, using their some rules, they can aggregate those information. So that's the aggregator. And then, so as I mentioned before, communication between FrontBit and FrontD will be secure. And then we're gonna use service mesh. That's the preferred solution choice. And Elasticsearch is a centralized data, so we can store Elasticsearch, the data stored in the Elasticsearch, and then we're gonna provide the visualization. So how to visualize the log data? We're gonna configure Kibana, and we are working on that. During the POC, we're gonna define the FrontBit, and we're gonna define the Elasticsearch, and we're going to define Kibana, customized Kibana configuration. We're going to see what the user can do, see, and what kind of information they can see. So we can provide it. So this reference implementation, if you can see, is totally out of the ONAP. It's totally decoupled from ONAP logging generation. So we handle separately. So some company, they have their own log component stack. So instead of using FrontBit, they are using something else, using some other component for our database, and then some other visualization tool. That's fine. We just focus on the generation of the log from ONAP components. That's all their responsibility. That's why we want to decouple the log generation from rest of functions. And then one important, this is the how to happen. I mentioned before FrontBit, and it's going to be node level logging agent and need to be run on every node. So we're gonna test with the daemon set, but we want to make sure we meet the requirement. All the application should run as a non-root user. That's the current input, and this is reference information. So previous slide I showed what we're gonna do, and this slide we're gonna talk about how we're gonna do it, how we're gonna achieve that. So most likely we are getting the resource for this, and most likely we're gonna start working on this Jakarta, and then probably we can continue to work on the con release. So this is a start, and then I think second, Bob and Amy and other team, they define the current the ONAP application logging scope. But if you see that the wiki page from SecCom, you can see there's additional discussion ongoing about platform level logging and other additional logging. So once it's done, then we're gonna collect the additional log information from various resources, various environment. But we think we can leverage the same architecture, since this is architecture meant to be flexible and then customizable. So we can leverage the same architecture to achieve our goals. So this is what I have today. Any questions, concern, feedback?
Ryan, a quick question. Would the architecture need to be changed if you have a different consumer of data, or you have applications or VNFs come in? Or would this be the same architecture?
I think I have pretty strong belief that we can leverage the same architecture, because as I mentioned before, we can have capability of the various different source collecting it. We can customize this input plugin. So if XNF and play, we can define where the log file will be and what kind of format, and based on that we can define, we can customize. So we don't have the high level architecture the structure, but we have some based on configuration we can achieve the goals. So I believe that we can reuse this architecture for additional resource. Did I answer your question?
Yes, it did. Thank you. If I can follow up, what should, if there are development communities attending or listening to this conversation, what should they care about it? Does that affect what they will do? Or if there is a user community representative listening to this, how does it impact them?
Is a question or?
Right. How does, I mean, what's the impact on developers, or what's the impact to a user of ONAP, like Bell Canada or Orange or somebody? Do they need to make changes, or it's optional?
I think the change could be minimum, because if they have their own way of the generation, because only they concern about the, here we talking ONAP, for example. I'm not sure I'm setting your question straight, but the idea is whatever they have additional customized component like Bell Canada, others, they the following the recommended the requirement ONAP does. So they generate their log file through the STDOUT. Okay, that's they need to meet, and then if they can use the reference implementation, they can use it. If they want to using their own way, they can swap the log component stack their own. So that's my belief. So I think the impact, I think there could be some configuration changes possible, but architecturally no changes to me. So we're developers from the companies, and then they are aware this is very flexible architecture, and then they only so during the reference implementation, we can document which is the touching point when the external developer need to customize. So we plan to document that one. So that means when they apply this architecture and the reference implementation, they know where to touch.
Thank you.
Yeah,
I think that's awesome.
Okay.
Yeah, just to just want to reiterate some of the key points Byung made there, because they're really important. With the approach that's here, if you're in a containerized, running in a containerized environment, and you have logging events, and if those logging events are going out to standard error or standard out, there's this sort of this architecture could really be used as a design pattern for the logging aggregation. The other quite easily, and then the other key point that's worth noting is that if you're in those containerized in a containerized environment, we have a good set of data. Here's the data that you should be logging that will allow you to create great security analytics downstream. And it's all traceable to good adversarial, good documentation of adversarial behavior. So I think the approach for has been that we're presenting today. The work was done for ONAP, but I think there are other projects that are looking to up their security logging game. There's a lot of lessons learned and a lot of things that could just be borrowed and taken from this and brought into those projects.
Thanks, Bob. I think that consistency among at least Linux Foundation projects for data collection, data logging, or analytics, that might be helpful if everybody's consistent. So the user community only have to worry about one architecture, one set of skills.
Yeah, that's important. Any other question?
Maggie, I have a question. Will these new pieces be available on the GitHub, or do you plan on building them into the ONAP product, or is that still under discussion?
It's under discussion, and I think that we are looking the reference implementation. And as I mentioned, this other than log generation is external to ONAP. So we're gonna put this. That's a very good question.
Okay.
Yeah.
So I'm just thinking about
how
it will be available for people to take advantage of this.
Yes. I think the reference implementation part of the ONAP GitHub, I guess, because is ONAP provide that implementation, and then probably the deliver the through ONAP. But that's my the current thinking. And then actually we are working on the reference implementation. Then we're gonna decide where we're gonna put it. So initially we tried to attach in the ONAP as existing kind of inactive, but we tried to find a home for this configuration, and then but we'll let you know about that. So we're gonna document. We're gonna let you know. Okay, thank you.
Thanks, Byung.
Yeah. So Byung, just to follow on what Maggie asked is the output of this effort. One part is that if you have any configuration, or if you are going to also distribute Fluent, Bitfluent, Elastic, and Kibana through your site, or you're just going to make a reference so people can use whatever is the latest. How is that documentation and instruction going to make it to user?
So I think that we plan to share the code for our configuration, for example, on Bit, and then we are providing the what we configured, how we're going to configure to the getting the log information. So like some there is the ONAP some configuration file. So we are going to share that one as a part of the source code control. So we have to do some source code control, so user can see they can download source code, and then they can customize. They can contribute to configuration. So anyway, it will be shared, and then also best practice and those things, and we can provide documentation, and also we're gonna documentation purpose, as I mentioned before. If the vendor they need to customize the configuration, we provide some kind of guidelines and how to change it, where to change it, and why we chose this option. So that's the one we want to discussed and shared through the documentation. But code-wise, actual configuration from bit, from D, and Elasticsearch in Kibana, we will leave the source code as a configuration. Okay.
Okay, thanks. And so expecting that there might be a mention of this in Jakarta or post-Jakarta release notes as a feature.
Yes.
And maybe some kind of indication where to go read more, right?
Yes, that's true.
Okay, thank you.
Guys, we have a question on the chat from Afulat.
Yeah, Byung, it's a question. It looks like it's a question for you. Okay. I'll read it out.
Yes. Okay. So
yeah.
Okay.
So yes.
Okay, yeah, I think he saw the ONAP wiki page about the logging architecture. If you look at the, I don't have the in the backup slide, but you can find the ONAP used to put the Firebit agent as a sidecar of the each component they are deploying Firebit sidecar, and then they export to the Logstash, and then Elasticsearch and Kibana. That's the existing the last effort from ONAP the platform perspective. The last effort to provide some containerized logging. So the currently we discuss about this the ONAP the OEM team others. They no longer interested in using the sidecar any longer, because the current global requirement of the ONAP component, they have to generate the log through the standard error. So initially we discovered the sidecar option for application in case application cannot generate the file through standard error. But all the ONAP component agreed, and they're gonna do a new way. And then as I mentioned, 80% is done, and then now 20% expected done in Jakarta timeframe. So we are changing, we simplifying the architecture. We don't need the sidecar any longer. So, and also Logstash, we see the some licensing issue. That's why we chose the front bit and front D combination before Elasticsearch. Hope I answered this question. So anyway, so if you have any concern and then those area, just send us the feedback to SECOM and ARCOM. So that was the reason. So it is not the first time people ask about Firebit, but we're not using the Firebit any longer. So it's no longer using the sidecar. So we don't need to. Anyway, that's the input. Okay. Any other question?
Thank you for this explanation. Okay. Guys, any questions? We have still 7 minutes left, so we can address 1 or 2 more questions. There is maybe some chat message.
Yeah, that's good. That's a good question.
So I'm wondering, Byung or Pavel, why beyond visualization or storage, analytics weren't considered in this effort, or is it something that you're considering in the future?
Good question.
What's the life cycle of data?
Yes, good question. I think that we discussed this at the second ones. This is the initial focus, and then later on, it's possible we can leverage analytic. So we have a bigger picture using the now we talk about CM the function. So I think after this is a kind of a low-hanging fruit, and after this we have a lot to do. So once we do the that's as you mentioned, we are moving into analytics, and then also just logging level analytic, and also some analytic requires some kind of a closed loop, and then how to coming back to ONAP. One possible is going to coming through DCA. But anyway, there's a lot of additional work to do. So current scope, SECOM define this is the current scope, but wiki page indicate there is the additional scope, not just for the XNF and SysLog, but there is the beyond this, and then we and Medusa mentioned about we're gonna deploy additional the analytic function in the future. That's the part of the things, but for now we focus on this. Did I answer the question, Medusa? Hello? Okay.
Yes,
Let's
thank
say-
you.
okay.
I think it's a good approach to take one thing at a time where you can produce the data first
Yeah,
and
I think the
standardize on it before you.
yes,
We
definitely.
need to, guys, also keep in mind that the consumer, I mean, the providers, the service providers, they might have their own selected analytics tools, right? So
Mhm.
maybe this would be a good choice to give also possibility to use those tools with some open interface and just to leave space for something that is already maybe developed or used as a commercial tool by service providers, right?
Yes, true. And when I think during discussion, when the vendor deployed their very, let's say, commercial quality CM products, they have very sophisticated analytic, in a way, analysis. And then based on the analysis, they define this is an attack or something else. Then they can engage the send the information back to ONAP to for ONAP to react. So those things, a lot of possibility here. And then many of them depends on the vendor use cases. So that's why the architectural principle separation of the log generation from rest of the function is very important, because ONAP cannot handle every situation. So we just provide the generation and additional generation possible in future release, and then logging and handling and annotating, and then controlling the control loop. Then that will be future discussion.
Okay, we have 3 minutes left. Any last question or comments before we close the session? Okay, I don't feel so. Thank you very much, Byung. Thank you, Bob, for really great presentation and sharing with the community the results of the work on multiple meetings. And it really took us some time to end up with these conclusions and all those fields and so on to be used for logging. So thank you for really great job done.
Thank you very much, Bob. Great job.
Yep.
Paul.
Thank you. Our pleasure.
Yeah. Bob, share now.
All right. Take care, everyone.
Yeah.